This is Geometries Unit 9, working on the review. We're looking for the slope formula. Slope formula is the change in y over the change in x. That would be that formula. The midpoint is the average of the x's and the average of the y's. And the distance formula, very similar to Pythagorean theorem, x squared minus or x2 minus x1 quantity squared, y2 minus y1 quantity squared. So there's our matching. If two lines are blank, then their slopes are opposite reciprocals. If two lines are perpendicular, if two slopes are equal, then the lines are parallel. So here, what we're going to look at is try to determine if the lines are parallel, perpendicular, or neither. Something different than that. So we first are going to figure out the slope of line 1, and that's going to be y1 minus y2. You can say y1 minus y2 and x1 minus x2, or you can start with the 2's. Either way, it doesn't matter which point, you just have to be consistent throughout the problem. We started with the point on the left, then we're going to start on the point with the left again. So that comes out to be 8 plus 1 and negative 3 plus 6. So this is 9 over 3, which is a slope of 3. The slope of line number 2 would be 25 minus 7 and 12 minus 6. That's going to become 18 over 6, which is also 3. They're both positive. They're both positive 3's, and they're obviously both the same. So these lines are parallel. So the slope of number 3 is negative 4 minus 0 and negative 1 minus 7 reduces down to 1/2. Slope number 4, 22 minus 8, 1 minus a negative 6, 14 over 7, 2. That would be negative, and that would be negative. Just being sure my signs are right, because they're reciprocals, but they're not opposites of each other. So I'm just being sure my work's right. 22 minus 8, 1 minus negative 6. Oh, negative 4 minus 0, and I have to start with the same point. So 7 minus a negative 1, that would become a positive 8, which would give you a negative. So these are perpendicular. There's your opposite reciprocals. We're going to write an equation that passes through line number 1. So line number 1 has 2 points, negative 3, 8, and negative 6, negative 1. So what is our equation that goes through those 2 points? Well, first we need to know the slope. So slope number 1 is 3. And then we're going to take the equation of y equals mx plus b. Plug the 3 in for the slope. Pick either one of those 2 points that you want to use, doesn't matter. The x is negative 3 and the y is 8 plus b. So 8 equals negative 9 plus b. Add the 9 to the other side, b equals 17. And that makes some sense because that looks pretty high compared to the direction it's going. So y equals 3x plus 17. Write an equation that goes through this point and is perpendicular to this line. So if we have a point at 4, 5, we have a line that's down here at 5, negative 5, and does a slope of negative 2, perpendicular to that is going to form a right angle. Now this is just an approximation, but it gives us an idea. We should expect a positive slope. It might be a relatively smaller slope compared to a large slope like 8 or 9. We know that the slope, if it's perpendicular, should be the opposite reciprocal. So if slope number 1 is negative 2, the perpendicular slope needs to be opposite of that, so positive, 1 over 2. This one is 2 over 1, so this needs to be 1 over 2. Then we're going to take our y equals mx plus b. We'll use our y, our m, and our x. So when we take half of 4, we get 2. Subtract that, and b equals 3. So if b is 3, I know that my slope is supposed to be a half plus 3. See if that makes some sense. We seem to be up there, maybe about 3 lines. And then it would be up and over, up and over. It seems reasonable. Want to be sure your answers make sense. If you know the math well enough, you should be able to recognize if answers are making sense. We're going to place the figure in a coordinate plane in a convenient way. That means standard position. We're going to do a rectangle. So we're going to have a point at the origin. We're going to have a point along the x-axis. We'll have a point along the y-axis. And if it's a rectangle, we're going to go straight up because we want to form right angles at every corner. If the width, we'll call it right to left, is a, so that was a comma 0. You cannot put 0 comma a there. You could put b comma 0, but you could not put 0 first. On this axis, we have to put 0 first because it's 0 right and left and up some distance. So I'm going to use the other letter there. Place the figure and find the side lengths. So the side lengths, we can label W, X, Y, Z, and Y would be A over B up. So of course, since we're vertical or horizontal, we can just count. WX would be able to count directly across that A distance. So the distance is A. X, Y, the A's are staying the same, so the distance from 0 up to a height of B is B. From Y to Z, we're going from an A down to 0, or 0 to an A. Distance is always positive, so it doesn't matter which way you think about it. And then WZ, we're going from a 0, which is the origin, up to a B, which gives you B. So we would expect a rectangle to have 2 sets of sides congruent. Number 10 on the other side. This one's one of the trickier ones of our questions. We're looking to put the coordinates in for this triangle, and we know that DG is the mid-segment. You need to know what a mid-segment is. A mid-segment connects 2 midpoints, 2 sides of a triangle, hitting their midpoint of each side and is parallel to the third side. It's also half the length of the third side. We're looking for the coordinates. That's all we have to show. So z, of course, z is on the x-axis, so the height is 0. If this mid-segment is supposed to be parallel to the slope of 0, then this c has to be the same coordinate as d. If the distance up, if these distances are supposed to be the same, it doesn't matter that it's slanted, it's just that they're supposed to be the same between each one, then it's got to be up twice as far as the midpoint. So if this is C, this has to be 2C. From there, to figure out these coordinates, you might be able to predict what this one would be, but we could use the midpoint formula. x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So if we're going to work with midpoint yx, then what we'd be looking for is 2b plus 0 over 2 and 2c minus 0 over 2. So that gives us 2b over 2, 2c over 2, which of course b comma c. So this is b. The midpoint of yz is 2a plus 2b over 2. Those are our x values. This formula should have been a plus. Doesn't change anything, but should be a plus. 0 plus 2c. So as long as you can divide into both sides of your sign, you're allowed to divide that out of a fraction. If it would only come out of one side, you are not allowed to reduce it. It has to come out of both sides. So this is a plus b. 0 plus 2c is just 2c, and that it can reduce. Again, you could think about it dividing 0. It's the same thing. So 0 divided by 2 is still 0. Here we divide it out and get c. So a plus b would be our coordinates. Then you could go through and do all the formulas and test it out to see if it was parallel, to see if it was half the length. All those would work with that. We're going to plot the points. We have m at 0, 0, n, O, and P. So there's our shape. Give the most specific name for this quadrilateral. Well, obviously all the sides aren't the same. And looking up here at this corner, they're not all rectangle. They're not all right angles, so it's not a rectangle. So let's see what happens when we start to do some calculations. MN. MN is horizontal, so we can count. So that's 3. PM is also, it's vertical, so it can be counted. It's 3. NO, that's slanted. We need to do the distance formula for NO. So we're going to use our 2 points up here. So we take x2 minus x1 and y2 minus y1. Negative 8 plus 3 quantity squared and 8 squared. Negative 5 squared and 64. So we get 25 and 64. That's 89, the square root of 89. That is NP. You can draw that in your picture if you wish. Then we'll come down and we'll do the calculation for OP. We're going to say 0 minus a negative 8 and 3 minus 8 gives us a positive 8 squared and a negative 5 squared. Notice that I have to use parentheses when I'm squaring a negative. So it looks familiar. We're getting 64 plus 25, which is the square root of 89. So here we have these two sides that are both 3 and these two sides that are both square root of 89. Notice that they're not opposite sides congruent. They are considered consecutive sides congruent. So we have two sets of consecutive sides congruent. Do you know what other shape makes that? So we'll look at the slope before we get our final answer. MN, because it's horizontal, we're expecting that to be 0. So we get 0 minus 0 and negative 3 minus 0. That's, of course, 0. NO, 8 minus 0 and negative 8 minus a negative 3. So we're going up 8 and to the left 5. OP, 3 minus 8 and 0 minus a negative 8. They're reciprocals of each other, but they're not opposites of each other, so that is not perpendicular. And then this last one should be undefined because it's vertical, but let's see what our calculations come up with. 3 minus 0 and 0 minus 0. Whenever you divide by a 0, you get undefined. Okay, so here we have a kite. We have two sets of congruent sides, or two sets of consecutive, that's the key. Sides congruent, and no parallel sides. That's the key, that is a kite. On our last page, we're looking at Owen, and he's going to take his first geometry exam. he needs to determine which figure has the most area. We need to show your work on how you would determine the area. We can break it up into triangles and rectangles, or we can use our trapezoid formula. Well, this is a trapezoid. This one is not. Figure 1 is a trapezoid. We have base 1. B1 is 1, 2, 3, 4, 5, 6, 7. B2, base number 2, is 4. The height, that has to be a perpendicular measurement. It's going to be straight up and down compared to our zero slope and an undefined slope. We have 5. So the area is going to equal half of base 1 plus base 2 times the height. So here we get 11 times 5, which is half of 55, which would be 27.5 units squared. So then we'll come over here to this one. This is not a trapezoid. Here we have one set of parallel sides, but it has too many sides to be a trapezoid. A trapezoid has to be a quadrilateral. So we're going to break this one into a triangle and a rectangle. This was a trapezoid. We're breaking this one up into a rectangle plus a triangle. The rectangle has an area 4, 5. So we have 4 times 5. And the area here, we're looking at a side length of, there's our 5. Now, if these were perpendicular to each other, they would have to have opposite reciprocal slopes. That might not be happening. But this side and this one are perpendicular to each other. So this is a length of 3. This is a length of 5. Of course, it's across from this side. So to find the area of a triangle, we say half of 5 times 3. So here we're going to get 20 and 7.5. We're going to get 27.5. We see that they have the same area. Neither one is bigger. To get a perfect score, Owen needs to determine the perimeter of figure 1. How would you figure out the perimeter of figure 1? Well, perimeter of figure 1 has 4 different sides. We have side 1, which is, we'll call a length of 4. Side 2, which is their height, which is 5. Side 3 is 7. And then we got to find the slanted height. The slanted height, to measure that, we could go from coordinate to coordinate, or you could break it into a triangle and think about it as Pythagorean theorem. Either way would work. We have the point 1, 2, and we have the point 4, 7. So we're going to say 7 minus 2 squared plus 4 minus 1 squared. 5 squared plus 3 squared gives us 25 plus 9, which is the square root of 34. So what we have 4 plus 5 plus 7 and the square root of 34. Square root of 34 is almost 6. So 13 plus 9 more gives you almost 22. So it's 21 point something. So the square root of 34 is going to give us this 5.83. So this comes out to be 21.83. Those are just units. We don't know if they're feet or inches or anything. Now if you look at our answer sheet, the answer sheet might say 21, but that clearly was a miscalculation. This should be the square root of 34, and it comes out to be, adding the other three sides, 2183. Madeline's new patio is scheduled to be poured this weekend. Each unit on the grid is 1 foot, so we're 1 foot over. Plot the following points. Classify the following figures. Show your calculations for side length and slope. Find the area and perimeter. So we plotted the points. We can connect those points. We have point A, B, C, and D. Now, we need to calculate the side lengths and the slope. So for AD, we're going to say x2 minus x1, y2 minus y1, so we're going to get 3 squared and 4 squared, which is 9 plus 16, square root of 25, which is 5. So this side is 5. The length of DC, that's horizontal, so we can just count it. That's 6. BC, I have a suspicion I know what the measurement is, but 11 minus 8 and 7 minus 3. So 3 squared and 4 squared, that gives us the same values we had before. We got 5. So that makes this a 3, 4, 5 triangle. That's a Pythagorean triple. Then our last side was AB, and AB was 6. So far we have opposite sides congruent. So we're not looking at a rhombus, we're not looking at a square because all the sides aren't the same. Let's look at the slopes. We're going to look at the slope of AD. M stands for slope of AD. So rise, 1, 2, 3, 4, up 4 over 3. And the slope of DC, because it's flat, it's rising up 0 and it's running 6, so that's a slope of 0. They are not opposite reciprocals, they're not the same, so these are just different. That means they intersect, but they're not making perpendicular. So there's no right angles with that. I can find the slope of BC. From B to C we go up 4 and over 3. So of course that's parallel to the opposite side. And 0, 6 gives us 0 again, so that's parallel. We have two sets of parallel sides with two sets of opposite sides congruent. So what shape would this be with that scenario? So that would be just a parallelogram. So the patio is going to be a parallelogram. If it costs $12 per square foot to repave this patio, what's our cost? So we need to find the area of this. We need to find the area and the perimeter. So to calculate the area we could break it into triangles. We could also use the fact that the area of any parallelogram is base times height. You just got to figure out what is the height. The base is 6. The height has to be perpendicular to that base. So we have to measure here for h to equal 4. This side was 6. So the area is going to be 6 times 4, which is 24. And they told us that each one was a foot, so feet squared. The perimeter is going to be 2 5s and 2 6s. So that's 10 plus 12, which is 22 feet. So if it costs $12 per square foot, we're going to say $12 times 24. So 12 times 24 gives us 288. $12 times 24 feet gives you $280 per foot. Not per foot, I'm sorry. $288 total. Okay, last one. If it were a rectangle, what would other possible dimensions, what could they have been to get the same area? We have an area of 24. So we could have had, we want other possible. So we could have had 8 by 3. We could have had 12 by 2. You could have had 24 by 1. Several different answers to have gotten the same area with a different dimensions. And if the dimensions change to get the same area, does the perimeter change? So this is the areas. What would the perimeters be? Well, if we had an 8 and a 3, we would be 2 times 8 and 2 times 3. 16 plus 6 is 22 feet. The perimeter here, we'd get 2 times 12, which is 24, plus 2 times 2. 24, or 2 times 2 is 4. 22, and that gives you 28. If one dimension was 24 and the other dimension was 1, so it would be 2 times 24 is 48, plus 2. So perimeter changes.